The sea lice count here is high, especially around the gills. This level of infestation is becoming a serious challenge for the industry.
All right, lower slowly now.
Copy that, easing tension on the main line, down another 5 meters.
Reading stable, continue deployment.
The impact of intensive salmon farming is starkly visible here. Layers of uneaten feed and fecal
The Salmon color score of 28 confirms the optimal astaxanthin pigmentation level, ensuring the premium pink-orange intensity consumers demand.
The rapid test confirms no detectable antibiotic residue in the salmon fillet, demonstrating compliance with premium food safety standards.
This bin is full, ready for transfer to the cages. All right, bring the crane over.
Look at this return rate on Sector 3.
That's a significant increase from last week's numbers.
Good, let's update the central database.
Total count is currently at 5 adults on this specimen. Documenting the load now.
These water quality logs show a significant variance here.
And this spike correlates directly with the antibiotic usage data.
Frequency increased here. What triggered this treatment cycle?
The count spiked unexpectedly. We initiated the rapid response protocol as detailed in this section.
A wide shot of the closed containment salmon farm, an alternative to open sea cages, utilizing RS technology that eliminates sea lice. This complex water treatment technology allows salmon to be farmed on land with minimal environmental impact. The chart illustrates the sharp decline in fish meal and oil substituted by vegetable proteins, resulting in significant
Stocking density is currently at 45 kilograms per cubic meter.
That puts us right at the commercial minimum for this cycle.
Look at the severity of the cataracts here.
Yes, the lens opacity is quite advanced in this group.
Examine the marbling and the deep color. This is the highest grade, essential for high-risk sashimi application.
The objective is transparency regarding sea lice and environmental impacts.
But the current data is simply not sustainable.
Next-generation aquaculture utilizes both land-based RS technology and advanced submersible cages to meet environmental and welfare challenges.
The large submersible cage is designed to operate in exposed locations far from wild salmon rivers.
In the spirit of transparency required by Norwegian regulations, we review the data on seabed impact, sea lice levels, and escape.
We're losing this river because of those farms. The numbers are dropping fast.
It's an outrage. We have to protect what's left before it's too late.
This cage is heavily infected. We must initiate treatment immediately.
Diagnostics confirm the bacterial load is...
We're seeing promising results in the disease resistance trials.
The genetic markers are stabilizing across fjords. The wrasse fish provides a sustainable biological control, diligently picking sea lice from the salmon.
If we optimize the filtration cycle, we can reduce water usage significantly
and bring that impact number down below 10%.
Unlike their farmed cousins kept in crowded cages, the wild salmon possesses the strength and freedom to conquer these falls.